Your line is now muted.
Good morning, everyone. Thank you for attending the COMCheck webinar. This webinar will be recorded, and the recording will be sent out to all attendees. If there are any issues with audio, please write in the chat. The chat can be generated by hovering over the bottom of your screen and clicking the little chat bubble. My name is Erica Duello. I'm a project manager for NORESCO. I have Gil here, and we've been working with the Colorado Energy Office to provide trainings just like this one. If your jurisdiction or company is in Colorado and has an interest in a presentation or technical assistance for code adoption, feel free to reach out to me. We have another couple webinars coming up on what we can expect from 2021, and that's on this upcoming Tuesday. And next Thursday is advanced framing methods. I will be sending you a short survey at the end of the presentation. If you could take a moment to answer these questions, I'll be using that data towards developing a code interpretation troubleshooting guide. Also, I will be muting everyone's lines to reduce background noise. Sometimes WebEx does act up, so if you could mute your line on your end as well, that'd be great. We do want to encourage questions throughout the presentation. So either if you would like to use the chat function or unmute your line and ask a question at any point, that would be great. And if you do write in the chat, I'll let our presenter know. Our presenter today is Gil Rossmiller, and he is kindly filling in for Shauna Mazingo today, so she can feel better soon. And so with that, I'll let Gil take the lead.
Great, thanks, Erica. Gil Rossmiller here with Colorado Code Consulting. And as Erica said, please ask questions anytime. Pretty open format. I've got a few slides here that we'll work through, show you how to work COMCheck and things of that nature. Hopefully we'll have some time here at the end. We'll actually go to the online version, COMCheck Web, and show you how that works and do a quick little plan and show you how that works just for fun. So this is me. I've been around the block a couple of times, started my construction career here in 1975. Gil was the guy shoveling sand for the concrete slabs and worked his way up through the ranks and started code compliance in 94. So about 20 years in, about 20 years out or so. Served on the IRC Plumbing and Mechanical Code Development Committee for the 9 and the 12. Commercial Energy Code Development Committee for the 15 and the 18, and just most recently the Residential Energy Code Development Committee for the 21, and then served there in Parker, Colorado as a building official for a little over a decade. So we had some fun. So today, COMCheck. So like I say, feel free, type in a question, ask anytime you wish. If I start to go by something that doesn't make any sense, because believe me, there's going to be plenty of things that I say that might seem a little outrageous. So we're going to take a look at our thermal envelope, certainly the mechanical screens, surface water heating screens, what we've got for interior, exterior lighting, talk about a few common mistakes that we typically see, and then take a look at, I don't know, some plan details maybe here, a few pieces. So we've got everything's free. So this software is free. There's no cost to it. It is updated every 3 years, and they're constantly, getting the bugs out of it. So there's updates every now and again. But you just go to departmentenergycodes.gov /COMCheck. There's the link there at the bottom. Just put in, COMCheck into your browser, and it'll pop up. The nice thing is that everything's been updated. You can get everything from the 2009 to the 2018 IECC, along with the ASHRAE standards that go along with it, the 7 through the 16. You can do it both for COMCheck Web, which is the online version, or you can download it to your PC. If you have a Mac, you cannot download the desktop version. You have to use the online version. They stopped doing it for Mac a couple of code cycles ago. So again, it's all free. And we're going to look at screenshots here today on how it actually, the designer would actually input the parameters of the building. So we're going to take a look at that. I think, I'm one that thinks that having at least an idea of what the software does and doesn't do is a good thing for all of us to know as reviewers than to just kind of assume that everything's being done correctly. There's going to be several things in here that we as human beings need to know and need to verify. So, for instance, we can do things, buildings that don't have 4 walls, don't have a roof, and don't have a floor, and it will show compliance. There are times when we want to do that, okay? There are times, and we'll look at that and talk about those situations. So anyway, it's all free, and that's the website. Here we just got a couple of quick screenshots. On the left-hand, upper left side there, that's what the desktop would look like. So the formatting is a little bit different, how they work. And, the buttons you push and the tabs and things of that nature are a little bit different, but they all end up at the same answers. They all have the same inputs. It's the same calculation method that's done in the background. So it's, as far as that's concerned, it doesn't change. So the screenshots we'll see today are going to be coming from the desktop version. And then if we've got time, hopefully we'll have a half hour or so at the end to go through, and we'll just actually open up COMCheck Web and do a simple shell building and throw in some, lights and stuff just for fun. Right? All right. So what do we got? Well, we've got all these prescriptive type requirements that we can deal with. We've got our R value based method. Okay, so that's straight out of the straight out of the table. And then we have this U factor, C factor, S factor method, which is time when they can actually then show you what their assembly U factor, C factor, F factor for slab on grade stuff is, rather than using the R value table. So you've got that table that deals with R values, and then the next table that then deals with just the U values and things of that nature. Then we have what we call the performance alternative. And what that is that's where COMCheck comes in. So that's going to be, we're going to take a look at that and see how that works. Then we've got fenestrations, which we're going to find out, which we can do some trade-offs on through our component performance alternative section. But that's about it on that. You're not going to be able to do solar heat gain, and we'll learn that here in a minute. Then, of course, as the previous slide says, you've got to do mandatory. You got to do all the mandatory stuff. So that's the air leakage stuff, any of the thermal envelope pieces that go with it. So we're, air sealing, things of that nature. Anything in the building, anything in the mechanical the piece, anything in the service water piece, anything. Of course, if we're doing IECC, we need to do this additional energy efficiency package, of which there are several choices. COMCheck takes that into account. And then very importantly, and probably as important as everything else, is this whole piece about the building operations and maintenance information. This also happens to be all the testing, the required testing that would happen on certain size systems. So COMCheck, we're using COMCheck, we do performance, we do anything. We're always going to do the mandatory stuff regardless. So as commercial, so we've been over this several times for those. Residential is anything, so there's a residential. So commercial is easy. So if it's not residential, it's commercial. I know, piece of cake, right? So the definition here for residential is detached 1 or 2 family dwellings. So we got multiple single family dwellings. So single family, a duplex, or single family, or townhouse, and any group R2, R3, or R4. But we've got to be 3 stories or less in height above grade. So we're looking at a picture here and we're going to end up having to use both. So we're going to make the grand assumption in this picture here that the first floor is a retail environment, or let's say it's a restaurant. We got umbrellas. Let's say it's an A2. So clearly not residential. It's going to be an A2. But let's pretend that the second and third floors there, let's say they're apartments. So that's going to be an R2. So clearly the building itself is 3 stories or less above grade plane. Looks like a 3-story building to me. But the first floor will be commercial requirements, and the second and third floors will be residential requirements. So remember, in the energy code, we've got it split. So we have commercial requirements. We have chapters 1 through 5 for commercial, and we have chapters 1 through 5 for residential. So that's how this building would be split. So if I had a building like this, and they wanted to do a trade-off on our thermal envelope, that's where the COMCheck comes in. It's the only piece that you're going to be able to trade off is the thermal envelope. No trade-offs on mechanical, surface water heating, interior or exterior lighting. It's a pass-fail. You either make it or you don't. Thermal envelope's the only place where you can trade off, and we'll show you places where folks usually get traded off on. So in this particular building, I'd get two. I'd get a res check if they wanted to trade off pieces on the second and third floor, and I'd get a COMCheck on the first floor. So clearly, let's see. So it says, any idea why being 3 stories or less matters in relation to the IECC? Apartment buildings get a lot taller than that. You betcha. They most certainly do. And so back in the day, there was a time, and this is Gil's opinion, if you start to ask some of the energy geeks that have been doing this for a while, the opinion seems to vary as to why we had a determination at 3 stories, okay? You're right, TJ, our occupancies could be 30, 40, 50, 60 stories tall. Absolutely they could. But when you look into the commercial piece, you're going to have different requirements then for our occupancies and then all other. So when you look at that table, you've got the 2 different columns to look at, and the same happens in 90.1. You can see that in different climate zones, you're going to see that the R values or the thermal envelope requirements are going to change slightly depending on the climate zone between walls, ceilings, floors, that type of thing. But the reason that we did it at 3 stories, at least my opinion, is that the general consensus was that once you get above 3 stories, the construction type changes. I know we see a lot of 4-story, 5A type buildings, wood type buildings. And now that we've got this TLT stuff, this big heavy timber stuff, where we're starting to see larger buildings, much taller buildings out of that, that might change. When we were in the code change process for the 18, I believe it was, there was not a lot, but some fairly major changes proposed to separate out R2s. So that R2s kind of got set out by themselves. So they'd have their own little space rather than this confusion between, 3 stories and 4 stories, things of that nature. It didn't pass. That didn't get through the code change process. So I don't know, remember, I don't even think it got through committee. There were a lot of things that needed to get fixed. So we made a few suggestions, and when it came back at public hearing, it didn't get through public hearing, and it certainly did get through on-light voting. In the 21, we didn't have any such thing. I don't believe anybody tried to do it. They just said, you know what, we're stuck with it, we're going to move on. Hopefully that answered your question. I'm sure that was a very long answer to a very short question. So that's kind of the reason for the 3-story. To me, I think it was construction type. Others have other opinions. But nobody seems to know definitively. All right, good stuff. Good question, CJ. Okay, so we kind of pointed this out earlier. We'll see the little drop down that we can find compliance with, and we're going to get everything from the 9 to the 18, of course, 7 to the 16, as it deals with ASHRAE. Yeah, so here's what we've got. So building thermal envelope is the only piece that you trade off on, period. 9 times out of 10, we see that the slab-on grade insulation is traded off, typically, not always, but that's fairly typical. When you deal with any of the mechanical systems, it's pass-fail. You either have the right efficiency and the right fans or you don't. Interior lighting, same thing. Interior and exterior lighting, same thing. You either meet the watts per square foot, or exterior lighting for parking lot lights, or light washing the building, lights lighting up the building. It's pass-fail. So you either do it or you don't. No trade-offs. Can't do it. This is a code section that allows COMCheck to work. Before the 15, there was no section like we had in the residential code, where it talked about the total UA trade-off. This is very similar. This is very similar to that. The piece that's underlined here is the piece that was added in 18. Okay? So the beauty of it is that in the bulk, in that first paragraph there, it basically says, hey, it doesn't care what the U value of any of your stuff is. Look at that, U, C, F factors in these tables, we don't care. And you can have as many windows as you want. That's what this maximum allowable fenestration area is in that section talks about. You know, as many windows as you want. So if I'm using COMCheck, okay, and COMCheck now works correctly, it didn't always, but it does now, that I could have 100% glazing on the outside. And if I've got really good windows, I'll be able to pass. And I won't have to go performance. Because if we do prescriptive in the energy code, at least commercially, if I get above 30% or 40% and don't provide anything above 40%, so 30% is our baseline. If I can increase to 40% window to wall area, if I have daylight, the daylight controls. But once above 40% and I'm doing the prescriptive path, I got to go performance unless I'm using COMCheck. If you can get COMCheck to work, more power to you. The underlying pieces here is the solar heat gain coefficient. So yeah, I might be able to ignore the U values for my fenestrations, but I can never ignore the values for the solar heat gain. Solar heat gain's got to meet the requirements of the code. Cannot trade off solar heat gain. You can trade off the U value, U factors, but you cannot trade off solar heat gain. And we'll see that the online program is a little that way, and I'll show you what that is. Here's the equation that they talk about. Basically, it's just a great big fancy spreadsheet. If you sat down, you could just make a spreadsheet on it and move on with life. Not that we're going to get into that, but this is the equation that it talks about. Honestly, I made a spreadsheet, and it actually works quite well, and which is what COMCheck is much more sophisticated than that. But what it boils down to is a spreadsheet. So it basically a trade-off on what the table allowed U values and maximum areas are, and what you are actually doing in your building. So that's what any of these softwares do. They create this identical twin, this geometric twin within the software. So the software, once I get the building built, software says, okay, if I built it per the code, this is what it would be. And now is the way I'm going to build it as good or better than the way the code would have done it. So it all goes back to the prescriptive tables as the baseline. All of them do the same thing. So here's that table that's not required. So if I'm using COMCheck, I don't care what this table says, because I can build it any way I want. Now, what we call the reference house within the software is coming back to this table here. It's the R value, or more specifically, the U value table. Okay? Doesn't matter. Don't have to worry about it. It's like, we don't care. Use what you want. but this is what the reference house will use. This is the table. Then we've got this maximum area piece. Remember that? Don't have to worry about it. Maximum area, we don't care. Much as you want. Much glass as you want. 100%, 60%. As long as the math works, as long as my quote total UA comes out to less, we're in good shape. Or the same. It could be identical. Doesn't matter. I think I have an example where it's exactly the same. So here is my fenestration table. And so we don't have to worry about the U factor up there, all the X's through it. All we've got to worry about in this table is the solar heat gain coefficient, whether it happens to be a skylight or vertical fenestration, vertical or horizontal, the difference between a window and a skylight. The things that are in blue there is the only thing that actually changed. So we had some solar heat gain coefficients change in climate zones 4 and 5. And for those of you that are unaware, it's all based on direction, okay? And what we call projection factor, and I'll show you what that means. We've got some wonderful little pictures that show you how that works in COMCheck. They got little pop-ups that are very, very nice that goes through, okay? So that's the section that actually allows COMCheck to work, and the nice little buffers and things that COMCheck will allow you to do. All right, so here's just a screenshot, and we're going to start here with this is what it would look like if I were to open up a project in COMCheck. This is the desktop version of it, and we start to pick what it is we want to do with it. Let's see what we did here. Okay, so we do a drop down on the code. We're going to have, obviously, much more choices in the 18 version. This is clearly a screenshot from an earlier version, but you go all the way up to the 15 and the 18. Then the codes you see below there, the 14 New York and Carolina, these are special ones, and so they have amended the code. So this brings up a great point. If you have amended the energy code so it no longer matches what the code says, you can you can use COMCheck, but you're going to have to figure something out. So for instance, let's say you make it such that it's more restrictive or more, quote, more energy efficient. So instead of saying you have to have an R20 wall as an example, no, it's got to be an R23, right? Something like that. You would have to figure out then how much percentage-wise they would have to pass by, and jurisdictions have done that. Jurisdictions will say, well, if you use COMCheck and you base it off, on this example, the 2012, we've actually made it more energy efficient, so you have to pass, your thermal envelope has to pass by at least 3%, as an example. Jurisdictions have done that. There are some jurisdictions that have made it less restrictive or, quote, less energy efficient. And you would do the same. You would just say, well, you could actually fail by 3% and still pass. And so the jurisdiction would have to figure that out. Then as far as the rest of these, they've just amended the COMCheck to do whatever Oregon or Ontario or Puerto Rico has done. These would be, of course, different in the latest versions. I think that Denver is actually working with them in ResCheck and COMCheck. Because Denver has increased energy efficiency quite a bit with their energy code. So I think they're working with the Department of Energy to get them to show up there in the bottom. Okay? So you just got to pick a code. Pick a code. So help topics. These are awesome. Man. These are really, really, really good. They have done I'd say, a very good job of giving you explicit, not only direction, but definitions and how they have developed it within the software. So when they say it's a wall, well, what kind of wall do you mean, right? If it's a block wall that's partially grouted, what does that mean? So that's good stuff. So a quick screenshot of that. And I think the desktop is a little bit better than the online piece of it. We'll double check that again today. Seems to me I like the desktop better. But they still have the same thing in it. I just think that this seems a little clearer. Maybe it's a format that I like better. But here again, this just air barrier options on the left. You've got the folder structure. You can look at screens and doors and windows and all the different types of construction types. And then it gives you a definition for it and the code section that's required. And then in this particular case, if you could scroll down, you'd see all the different materials that an air barrier could be. Same thing with the code list, plywood, OSB, foam, all the different pieces that go on in that list. So if you get stuck, I go back to this pretty regularly. If I start to forget, or it's a good reminder, or there's a certain construction assembly that comes up and you're thinking, what is that all about? Just go back into this help piece and see if there's a good definition, or at least helps you understand what the software is doing and the assumptions that the software makes, because the software has its own defaults. And we'll talk about that here in a second. So here, project, we're just picking out the location. So it's got all the states in there. It's got most of the cities in there. The directions are, if you don't happen to, if your city doesn't happen to show up, pick one that's close. There was a time Parker wasn't in it. Denver was the closest one, but now actually Parker's in there. So they've got quite a few cities in there. This one happened to be picking new construction. This is the slide. So we've got these energy efficiency options, and this is kind of nice because what the software does now is it actually keeps track, of it. So there's obviously far more choices now than there was in 2012, 18. I think there's 7 or 8, maybe 9 different ones that you can pick. The beauty of it is that once we pick one, it needs to be throughout. And this is one of the mistakes that we start to see. And it's not that uncommon. What ends up happening is if we have a COMCheck that's done, you might have the cat that does the COMCheck for the thermal envelope. And then you might have the mechanical guy that does it, for the HVAC heating and cooling systems and surface water heating. And then you might have the electrical designer do for the interior and exterior lighting. And that might be 3 separate COMChecks that they're creating, and they may not pick all the same options. So what you don't want to have is a COMCheck that shows up, and we'll show you where it shows out on the printout. You'll have the envelope says, we're going to use the reduced lighting power. Perfect. And then you look up in the lighting piece, and the lighting piece says, no, we're actually using the high-performance HVAC. And what? No. Well, then you open up the mechanical report, and it says, no, actually we're using on-site renewable energy. No, you cannot do that. It's all got to be the same. Because the beauty of it is, and what makes this really nice, is once you pick one, it is automatically done. So meaning, the reduced lighting power, I've got to reduce it by 10%, or I'm only allowed 90% of what the code says. It is automatically applied when I go to do my interior lighting. So it does it for you automatically. It won't say that you passed. Even if you put it in basically what the code says, if I pick reduced lighting power, well, wait a minute, it's got to be 10% less, and it'll say fail. So it's automatically done, which is nice. It's a nice little feature. Then we've got the different air barrier options here. We've got the air barrier permeability, which is just that big list that we've got. The assembly piece, which is I have a certain assembly, the plywood or whatever the assembly is, the sheetrock and the studs, and they can have a test. They can actually test the assembly if they wish, or they can decide to do a blower door, and that's still the same in 2018. That is not a requirement. Blower door is not a requirement for commercial buildings in the 2018. It still remains not required. So we've got project details, so we've got building envelope areas that we need to put in here. So we're still on our very first tab. So we've got tabs here that we're starting to fill out. So this is the first tab, project, building envelope area types. We got to get those put in, or it won't let us go any farther. It'll keep saying not done. Now here we're just picking out what the building type is, and this list goes on. So we just pick what it is. And we can have different building types, right? So we might have different pieces within a building, which is fine. And then we just pick an office. I just picked office for this particular example. We put what the area is. I didn't decide to put in an area description. The designer could certainly do that. And then is it residential or non-residential? Well, office is pretty obvious. It's non-residential. So that's pretty clear. You'll be able to see that on the report too. And then you'll notice that we've switched tabs here. So we've moved from building envelope areas to interior lighting method and areas. So we've got two different choices here. Building area method. We've always, we've had this since 2015, and Ashley's had this forever. Building areas, I would just take the entire building. So if it's an office, I'd say the whole entire building's an office. The office has no hallways, it has no conference rooms, it has no bathrooms, it has, no storage areas. It's just all the wattage is the same throughout the building. Then, as I've selected here, we have this space-by-space method piece. This is a fairly popular one because you get more bang for your buck. Now you can actually go to different spaces and say, okay, I've got a fruit pep area, I've got lobby areas, I've got office areas that are open or enclosed, I got a restroom, I got a stairway, I got storage. And so we can go on all these different types to get these choices to say, oh, well, I want so many watts per square foot here and here and here. And the biggest bang for the buck is the retail. Retail areas, you really get the big bang for your buck. Retail areas, you can really pile on the wattage for the sales areas, depending on what you're selling. There's 3 or 4 different increases that you can get so that you can have more light on your clothing or on your jewelry or your pottery or what your pictures, whatever it is that you're selling. So you can really get a lot. And what you can't do if you pick building area, you can't do that. It's just straight wattage per square foot. So that's why you'll see a lot of space-by-space methods. And then we do the same thing. So on exterior lighting areas, we've got a couple of choices here. We got to, first of all, work with our planning and zoning department to figure out what kind of area it is. And in the code, there's actually four different areas that it gives you different wattage allowances for these different areas. So residential or residential mixed use, national parks, right? We got rural areas or high activity metropolitan commercial districts like downtown Denver, for instance. So you get to decide how much watts you can have for your parking lot lights, for your lights that are washing your building and walks and entrances, all the different areas. And with exterior areas, you get a base allowance in the very beginning. And of course, each of these areas, the brighter that you can have it, so obviously a high activity area is going to have the highest wattage. So you just look out for that. So for instance, if they're picking high activity metro commercial district and it's clearly a residential area that they're putting this in, maybe the zoning doesn't want to happen. Back in the day, I used to have planning and zoning. I used to have we would do the exterior lighting compliance when it was going through the planning and zoning process because, of course, they're very intense on, dark skies and not allowing light to flow over onto the neighbor's lawn, neighbor's things. And so you don't have bright lights on all night, that kind of thing. I like to do it back in the day before the advent of all the LEDs and all the very highly efficient lights we have today, because many times it failed when it finally came to me. And I didn't want to have to go back through planning and all that. These days now, with the advent of LED, I rarely see any any exterior stuff fail, just because of the technology that we have today. Let's see. So I picked a neighborhood business district just for something to do. Then we can actually go through and say, well, what do we got? All kinds of different choices, different lighting allowances for main entries or parking ways or driveways or the entry canopy. You're going to have exemptions that you can put in here, emergency services, loading area, things of that nature. There's going to be things that are exempt for this. So anything that has to do with, life safety, means of egress, any of that type of thing, or, maybe it's a high crime area, as example. They always want the alleys in the back of these buildings lit, which would be perfectly acceptable. That would be exempt from any of the wattage requirements, as an example. So they just pick what they've got, ATMs, where they have walkways, stairs, any of that. If they've got it, they can use it, not a problem. So we have now switched. So that's kind of our project tab, where our project information goes, and now we've skipped over to envelope. And so here, we're just selecting what is it we got. So we've got all kinds of different categories here when we're dealing with a roof. I just started with a roof, right? Insulation above the deck. We've got metal buildings, standing seam, metal building screw down, attic, roof with wood joist, attic with steel joist, and then we've got this other option, which we'll get to. All of them got an other, and I'll show you what that is here. I just, in this particular case, said insulation entirely above deck, and of course what popped in there was what we had in the very beginning. Remember, we actually put in that office piece in our project tab. So if I had several different areas, I could separate the roofs out. So while I'm at that, you can glom together or put together all like assemblies. And you'll notice that I'm not using an orientation here. You don't have to use an orientation. Okay? You can actually put all together. If all the roofs are the same insulation value, all over the entire roof, you can just put one roof in. The only time you'd have to do another roof is if it had a different assembly. So let's say you got some that, have an R30 above the deck, and let's say you got some that aren't, well, they're only an R20 for whatever reason. Or I've got two different types of roof. I've got some flat roof where it's all above deck or, above the deck, and I might have some vented attic space. I mean, that's absolutely possible. So it's depending on how many different roof type assemblies you've got, but if it's all the same, you only need to put in one. Okay. Then if we're putting in an exterior wall, I actually put concrete there, and we get is it lightweight, medium weight, or what they call normal weight? And now you're going to say, what does that mean? Well, you go into help and you see how they define that. They will define what lightweight, medium weight, and normal weight is. I think I just put in medium for fun of it. Then let's say, what am I going to do? Am I actually going to fur out that wall? Am I going to put any furring on it? So if I furred it out, is it wood? Is it metal furring? Or did I do any at all? Because it's going to default to none. You got to tell what it's going to do. Then I need to put in what the gross area is, so I filled in the gross area. Then you'll notice I said, well, I put in furring wood, and then I said, that's, well, I don't know, 5,000 square feet. I said, all right, we'll put an R13 cavity. Then is there any continuous insulation? So another kind of, not totally common, but what you'll see every once in a while on a wall assembly is that you might see a continuous insulation of R1 or R2, just very small. Well, the designer will come back and say, well, we do that because, there's sheetrock on the wall, or, we put some siding on the outside, something. Well, the software already takes that into account. It already does it. And those are some of the defaults within the system. And so let's say I were to pick a block wall or a wood wall, okay? It's going to have the assumption of what the framing factor is, meaning how much of the, if I'm doing cavity insulation, for instance, how much of the wall is insulation and how much of the wall is wood. Because if I don't have continuous insulation, I've got a thermal break where the wood is. Yes? Yes, absolutely. And so it already has the quote R values for all of my exterior siding, my sheetrock, any vapor retarders I put in there, what they call air films on the inside and the outside. If I, sheathing, it's already in the software. All the software wants to know is, what am I doing for cavity and what am I doing for continuous? Because it would be in addition to any of those other assembly pieces, sheathing, sheetrock, that stuff, already in there. That's why there's the other category, and we'll give you an example of that. Do not panic. We will give you an example. So anyway, this one, I don't think I put any continuous, and here we get all the different types. So we got wood frame, 1624, steel frame, 1624, metal building. Okay, so we've got a steel frame building, difference between a steel frame building and a metal building. So steel frame building is going to be steel I-beams and metal studs, essentially. So we got I-beams that are pretty much a structure, and then steel studs that run between it or in front of them, just to create the exterior walls. Metal building would be like a Butler building, where we've got purlins, giant superstructure, and then purlins or girts for the walls, and then we've got insulation that's going to be sandwiched in between them. So here, again, we run into all different sets. So if I pick solid concrete, or I come down here and I pick a concrete block, well, then I get a whole bunch of other choices. Well, what is it? Well, you tell me, because is it 6, 8, 10 inches, partially grouted? And then you're going to say, oh, well, if it's partially grouted, cells empty, what does that mean? Well, we can go back to help. What does partially grouted, cells insulated mean? Well, go back to the definition. Now, there are limits to how many of those cores can be filled, grouted. So we've got vertical cores that'll be filled. I mean, they're all going to be reinforced. I don't know how many unreinforced buildings we get built these days, unreinforced masonry. I don't know that we do. Then we've got what this insulated means. What's that mean? So there's limits on how much can be actually filled full of cement or grout, and how many cells are actually insulated, and that's basically vermiculite or something. They've got foams. I've seen some pretty outrageous claims from companies that actually have foam products that fill the empty cells with expansion type foam. They say it's just like continuous. It's not. Continuous means continuous across the entire face of the framing members. So if I happen to be using concrete block, I'm using an 8-inch partially grouted, cells insulated concrete block, it would already have the U value for that. You would simply add any other insulation for that assembly. So if you didn't fur it out, there would be 0 cavities. And if they did not put continuous insulation, sheet foam or spray foam, something, on the outside or the inside, no insulation would be added to that assembly. It would just be what the software says the U value was. Okay? All right. So we just happen to say furring none. We don't have any cavity or continuous, so I just set that in there for fun. All right. So let's say other. So now we're going to get into this whole other piece. And this you will see on commercial buildings far more than you will see on a residential building. And what this allows the designer to do is to design their own wall, okay, or their own roof, or their own floor, because they all have this option. meaning, you know what, I really don't like what COMCheck does for defaults. I really don't like my R values for the sheathing or the decking. And you know what, my framing factor is a whole lot better than what they say it is. Okay? So once I pick one of those, this is what you get. This is the little warning that comes up to the designer. You never see it. You never see it on a report. You'd only see it if you'd actually do one. It says, assemblies with a known assembly U factor enter the overall assembly U factor for the assembly in the U factor field. The U factor is assumed to be consistent throughout the entire assembly. So what that statement is saying is, if I build a wall, half-inch, I got 2 inches of foam on the inside or outside, and half-inch OSB and 16 on center metal studs and 5/8 sheetrock. It's that way throughout the entire building. Okay. Then the most important piece is documentation must be submitted verifying the overall U factor assembly. Must be developed in accordance with accepted engineering practice. So what they're talking about is the ASHRAE Book of Fundamentals. Okay. So what we're going to look at here is just a really simple wall assembly. Nothing particularly fancy here, but it gives you an idea of how and what you should be looking for. Okay. So we have R value at the insulation itself. Yes. Okay. We're going to have an R value at the stud. So we kind of have two different columns going on here. Because we have cavity insulation in this assembly, there's going to be a thermal break at the stud itself. So as I start to look down to the very top here, we've got 0.17, and that is my exterior air film. So these do have an R value. It's in the ASHRAE Book of Fundamentals, and what I'm using here is the generic ones that are generally accepted. So if you see anything different than this, it shouldn't be too different. It should be pretty close to what this example says, regardless of the assembly. So we got a 0.17. Then we come down to my half-inch wood. It's got an R value of 0.18. Oh, well, we'll get to that. Then I've got, looks like a 1-inch insulating board. Got an R value of 3.57. It's the same at the insulation, yes, as it is at the stud because it's continuous. It's over the top of the stud. Then the next piece we got is the 13 bat. So I said, oh, this has got an R13 bat. So the R value at the R13 bat is 13. But the R value at the stud, since there's no insulation there, is going to be that 4.55. That's a 3.5-inch stud, 1.5 by 3.5-inch stud. Then we've got our gypsum board here at a 0.45, and it's going to be the same at the insulation as at the stud, and same with our inside air film. Now we can add this up. You can add R values. You cannot add U values. Okay? Basic principle, you can't do it. So what we do is we add the two. So the insulation that we've got at the stud is a little over 18, and the R value at the stud is a little over 10. Well, now what do we do? Well, now we got to figure out what my, quote, framing factor is. And so how much of the wall is wood and how much of the wall is insulation? And so I'm going to say it's 20%. I'm just going to go out on a limb and say it's 20% as an example. Well, now we can actually do just some math here. So 80% of my wall is at 18.68, so 0.8 times that. Then we're going to add to that 20% of my wall, which is at R10.23. So we do the math, add those together. We get an overall, quote, R value of this just short of 17. So they're reciprocal from each other, U values and R values. So 1 divided by the R value equals the U value, and 1 divided by the U value equals the R value. Okay? So we take 1 divided by our 16.98, and we end up with the assembly U value of 0.059. So it might be slightly better than what the code says. This is also what you would expect to see if they were using that U factor alternative. That second table is not the R value table, but the U value table. Let's say they wanted to use the U value table and not use COMCheck. This is the kind of calculation you'd want to see for all their assemblies to show, or whichever assemblies they decide to use, take exception to, they can do that. You may have seen this before, may not, but it's not unusual to see 4 commercial buildings in any way. Okay, moving on. Oh, Windows. Probably the biggest error that we see. And it will take education from our plans examiners, believe me. This is something that is probably the most overlooked and least understood when we are dealing with commercial thermal envelopes. And we'll walk through this. I'll get you through some screenshots here and then kind of fill you in what I'm talking about. So we've got some choices here when we select a fenestration. So we've got NFR site built. It's going to be basically commercial products only. So we've got site built pieces. So if we pick site built, we can actually go into, and they're getting a little bit better at this. So the CPD ID number is a number that a manufacturer would have, or the window folks would have, if the entire assembly has been through the CMA or CMAS process. Okay? So do a little education here. When was the last time, so ask yourself, when was the last time you walked up into a commercial building and you saw that little NFRC sticker like you see on every residential style window, on a commercial window? Think hard. Not very often, if ever. So why is that? So why don't we see a sticker like we see a sticker on residential windows? Well, residential windows, Anderson or Pella or Milgard, any of these large manufacturers, they build a style of window. Same glass, same spacer, same frame, a million times over. And so they have that particular frame, spacer, glass, and tested. Actually, tested itself. Then the factory is authorized to put the sticker right on the window. They just put the sticker right on the window, out the door it goes and gets delivered. Great system. Now, the unfortunate part with commercial windows is think about how many different types of glass there is. Think about how many types of spacers within the glass, within that thermal plane, double or triple glaze, there is, and how many different types of commercial frames. A lot. Hundreds of thousands of different combinations. So NFRC has a software that will then give a rating based on a NFRC size. So it's not the actual size of the window, so they have a test size. What they have is a gigantic database of all the different tests for all the individual components. So the glass, the spacer, and the frame itself. All the different frame types, glass types, and spacers. And what the software does then is it then gives you a calculated U value that you can use for code. And I'll show you an example of what that looks like here. We have a slide or two ahead. The beauty of it is if they happen to have one of these numbers, which I kind of doubt, they could actually type it in here, hit that little button that says search the NFRC database, and up would come all the data. So you hit the little hit data button and it all load in there. Depending on if the test has already been done, it may not be, and it'll just come, I can't find anything. 9 times out of 10, they won't have it because this is how the system works. They will not be able to do the actual software comparison until that engineer who's now authorized to use the CMAS software, he won't, or they won't actually do that until the windows for that job have been ordered. And the reason for that is they need to be fairly certain that what they're actually given the document to will actually be the product that shows up on the job site. So unless they've already done that, they won't have a CPD ID number. And they cannot use this report from a different project, even if they're using the same windows. It's project specific. How the NFRC's got it set up. So that's that piece of it. It's rare. I think I've actually seen one project that came in with a CPD ID number that was actually for that site. I have seen others with a CPD ID number that was not site specific, and I said, well, give me site specific, and I'll buy off. Okay? And I'll show you what they look like. Don't worry, it's a few slides ahead here. Then we have this next piece that we could choose, and this is the one that you're going to be seeing because it's the only one that works if they don't have a CPD ID. And we'll get to energy code defaults here in a moment. So now it's going to say, you know what, we're actually going to have it, we're going to have it evaluated, but it's pending ID. So the designer can fill in these numbers, say it's pending ID, hit OK, and in goes COMCheck. So the only thing that they can't manipulate, meaning that they have to meet the prescriptive code with, is the solar heat gain coefficient. If they put the solar heat gain coefficient and it's not correct, up will the screen will say, you know what, can't use it, wrong, you got to have a lower solar heat gain, it's too high. And that's what so the software will come up with a little thing to the designer saying can't do it. So here, now I've picked the energy code defaults. And this is what you're going to get, and it's correct. So depending on where you are, you can't use the defaults because the defaults in that table, so that's in the table C30 something, that talks about, well, it's not even a table. Well, I guess it is a table. That says, well, if I don't have an NFRC certificate, thou shalt use the energy code default. Well, that's really tough because it won't let you, because the solar heat gain coefficient is way high. Right? So it says, hey, it's got to be 0.51. Well, when you try to go in there and change it, it won't let you. So it's hard to use it. The reason we still have the energy code defaults is mostly for existing buildings, and we can still do that for existing buildings, but you're not going to be able to do it for new construction. Okay, because existing buildings are trying to trade stuff up, maybe you're not replacing the windows. Maybe there's another reason. You're putting in an addition and you want the whole building to comply instead. That kind of thing. Okay? All right. So now let's see what we got. Doors. Yeah, don't worry. We're going to get to that. I don't know why I don't have it yet. Maybe I have it toward the end. But I do have examples of what we would use for plan review on the for the U values and solar heat gain coefficients, and what document you should see in the end, because you won't see the actual the CMAS or the CMA certificate until the windows are showing up at the job site. But there is a document that we can get for plan review purposes, and I do have an example of that. It just must be later in the slides. Sorry about that. So teases you, keeps you on the webinar. Yeah, I know, it's so intense. Okay, so now we just go through the other different components here. We got doors. We've got projection factors. Again, so glazing. So if we've got doors that we're putting in, is it insulated, metal, is it wood, glass? So if anything greater than 50%, it's considered a fenestration. You'll have to make the window U values. Otherwise, if it's less than 50%, it meets the opaque values. Here's this Projection factor, this again comes out of the help piece, and it actually, when you're inputting that and you're using projection factors, this will actually pop up within software and say, how does it work? Well, this is how it works. And you'll notice if you remember when we were looking at that table for fenestrations out of the code, you'll notice it had projection factor. It had PF there at the top. So this is the map. So you got A, which is the projecting element, whatever the shading device is, soffit or shading device. Will certainly be that. And it's divided by whatever the bottom of the shading device is to the bottom of the window. Do the math, that's your projection factor. And that's what you would enter in. When we get into basement walls, a lot less like COMCheck, for those of us that were back, joined us for that, same kind of thing. And crawl space walls would be the same thing. We get this nice little picture that says, hey, you know, how deep is the insulation and how far below grade is it? And you put the numbers in, the designer just types the numbers in, and it does the math. Here's the nice little piece that comes up when we deal with slab on grade. Again, this right here is probably one of the biggies that they don't get. They might show that their slab on grade has insulation. They might say, you know what, it's got an R10 and we're 24 inches, just like I'm supposed to be. But yet when you look at the construction details, they all stop right at the bottom of the slab. So rather than coming all the way top, like it's supposed to be here in the picture, it stops right at the bottom. That does not count. You cannot allow that to work. You can do any of these things in this particular picture. You can do upper left there that's got little a, it'll be on the inside, it can be the outside, it could be vertical, it could be horizontal, it could be vertical and horizontal. It could be both, it could be all of it. But what you can't do is not start at the top of the slab. It has to include the top of the slab. Otherwise, it doesn't work. Here, it's just asking more questions about, you know, what's the depth? How is it working? Is it horizontal with vertical? Is it vertical only? And it's just saying, hey, what have you done? That way we can calculate what's going on, and we can actually then decide what's going on. So we do it horizontal, we do it vertical. I don't care as long as you do something. And if you do nothing, it would enter 0. You would still enter it into the COMCheck, insulated or not, because that's how you trade it off. So if I'm not going to put in insulation, I've still got to put in, say, it's linear footage too. That is the key. I think that's the next, running length. So we're actually doing linear footage. It is the only input. The only input it is done in linear footage. Everything else is gross area. I didn't say that before. So when I'm putting in my exterior wall, so you see that input there? I've got exterior wall. I said it was solid concrete. And notice how the window and the door are connected to that wall. That means, so I put in gross areas. So in that case, I put in 5,000 square feet. That means that it knows that I'm deducting out of that gross area, I'm deducting 600 square feet out of there because I got 500 square feet of window, I got 100 square feet of door. So that's why I use gross areas only. Do not deduct, windows and doors out of the gross wall area. The software does it for you. This is the pop-up that you get whenever you're doing slab on grade. This little pop-up will come up, at least in the desktop software, that says, hey, do it in linear footage. All right.
Hey, Gail, looks like we have a question from Morgan.
Oh, what would you do if you had, yes, thank you. What would we do if you have termite issues? Then the code loses. Energy code loses. So the only way that we're going to get away with the termite thing is you don't put insulation on the outside. So if you're in a heavy termite area, your jurisdiction might decide, you know what, we're good and we're just moving on with life. We're not going to even require that you do it. Okay? There are jurisdictions that say, yeah, you're right, you can't do it, so you have to trade it off. So I don't know. I'm no termite expert, nor have I lived in an area where that's been an issue. So I don't know. Can you still do insulation on the inside? Yeah, because if you're doing it on the outside, so if we go back to that picture, clearly if we're doing something like this on the outside, this is bad news. It just gives them a path right inside the building. But can you do it on the inside of the building? Is that possible? Can you do the inside, or is that still, I don't know. Does that still then give them that path to the inside of the building? I don't know the answer to that. Yeah, that's tough. I mean, there are actually, what was I reading the other day? It was, I'm trying to think, it was some sort of foam or something that they actually built in, some sort of termite business into the foam itself, and that seemed to work. I just have a faint memory of that. So anyway, that's unknown, because there is an exception in the code. There is an exception in the code that talks about that. So let's see. Hopefully you're seeing the codes now, and it's going to be specific thermal stuff. Slab on grade. I thought there used to be an exception for that. I am not seeing it anymore. Yeah, there used to be heavy termite stuff, but as I've said before, there are plenty of times when the energy code loses, and that might be one of them, because clearly that's a bad thing. Clearly that's bad. So that's great. Good question. Very good question. Slab on grade. Done with that's the thermal envelopes. Now we're moving on to interior lighting. Pretty straightforward. Then we're just basically entering what it is they've got. It's pass fail, pretty black and white. So when they do any type of lighting, they've got all kinds of drop downs here as to what type they're doing. Then they pick whatever type that they're doing here. Then we've got all kinds of different choices here, and there's even more now in the 18. We're getting into more of the LED stuff. We don't see any LEDs here back in 2012, but they got LED choices now for any of the lights. And then, of course, there's other in here for anything that the software doesn't have to have. Then we're just looking at whatever documentation that they've given us to say, oh, okay, well, they've used other, and these are the lamps that they're using, and this is how many watts they've got, and this is how many they have. So we just kind of walk through. They give us the ballast here. They give us how many lamps we got. Okay, how many lamps you got in each of the fixtures. How many fixtures do you have? And what the fixture wattage is going to be. Track lighting is a little bit different. I don't know that I'd give an example of that, but it's basically how many watts it can have. I think I might have a few screenshots. But honestly, it's just what lights do they have, and they put them in. It's just a way of actually showing compliance for it. Here's track lighting. So we've got all kinds of different things that we do and still comply with code. We've got all kinds of different choices. We got circuit breaker capacity, track wattage itself, current limiting devices, and if we're doing low voltage type track lighting, we're just looking at what the transformer is doing. Track lighting here, again, they just give a little piece about what it is. I would go on to the 15 and the 18 and the newer stuff. We get choices here with the new codes, and it's the same for the 18 now, depending on what they're doing. 30 watts a linear foot, the breaker, or wattage, limiting device, because now back in the day, you had track lights that might be rated for 100 watts a foot. You could really load those bad boys up. And the code said, guess what? You're going to do what it can take. That's the killer. Track wattage here, they just get the different drop downs. Then just tell us what it is. What are you doing? What's it actually at, and what do you get? Because it's what the track can do. Because this is probably one of the biggest things that happens. The designer says, yeah, they're going to do X, and they put it in, and then we walk in, and guess what? They don't have one 8-foot tracks. They got 10 8-foot tracks, and now they're in trouble. They say, oh, well, we're going to take out back in the day, it was, we're going to take out the incandescent bulbs and put in LEDs for complex fluorescence or something. Not particularly code allowed, but there were times. Fixture library, this is just a place for your designer where they can put in, let's say they use these fixtures every single time, or this is something that is very typical for them to do. They can just create a library of different fixtures and just say, hey, I'm going to pick from my library, just do this, this, and this, and this, and that way they don't have to go through all the different steps. Just makes it simpler for them to do it. Exterior lighting, same thing. Pretty much the same deal. We just start to pick what it is that we're doing. LEDs and what's the watts, or panels or other types of fixtures or others, or all kinds of different lamps. And if they don't show it, put in others, get the documentation, and there's just a count. We have that, how many lamps per number of fixtures, and what we got for wattage. These are just obviously screenshots from the whole picture, but they would just go light, depending on the parking area. I remember those exterior lighting areas. Same thing with the interior lighting areas. That would have been done on that project tab. So if we had 5 different types of exterior lighting areas, we would have put that in our project tab back in the beginning, and they would have showed up here automatically. Then we would have just then accounted for what we were putting in those areas. And we just verify that with the plans, what's going on. So when we get to mechanical piece, again, it's what are they doing? They central furnace, we got a duct, hydronic, we got a heat pump, we have like PTAX there, that's that package terminal unit. We got maybe some radiant heaters in there. Do we have maybe a unit heater? Same thing with cooling. What's going on? What do we have? Typically what we're going to see is a ducted furnace, yes, and a packaged terminal DX unit. Pretty typical, especially on these strip malls, 10 finishes, that type of thing. That's fairly typical. Then, we've got single packaged, DX units. It's just an air conditioner by itself, and then a split systems. And then we've got, or is it zoned? Is it a single zone, multiple zones? The designer just picks what they got. So we got, I just said we had, central furnace, and I don't know, I picked single package DX unit. Then we just pick, is it electric? What kind of fossil fuel are we using? Then is it air cooled? Do we have an evaporative cool? Is it water cooled? Do we have a cooling tower? That kind of thing. Well, this one's going to be obviously pretty much air cooled. Then it gets into this economizer piece. So economizers are free air conditioning, and for especially those of us there in Colorado, that's a big deal. That's a big deal. Needing to have it's free air conditioning. All that really is it's a damper that opens up and it just lets the outside air in and cools the building. So if it's 65 degrees out and I want the building to be 75, you just open the outside air. You don't have to run the air conditioning. And the beauty of it is that back in the day it was 34. Now it's 54 in the 18. It won't let you not put in one if the climate zone that we picked in the very beginning, Parker, and that would happen to be climate zone 5B, it already knows, you know what? You got to have an economizer, so you can't not put one in. So it's nice in that the software just says, no, it's required, guys. You got to do something. So you got a little pop-up. And it knows it's been updated every 3 years. We update the efficiencies on all the different conditioning appliances, all heating and cooling equipment, fans, all kinds of stuff. Okay, every single code cycle are updated basically through ASHRAE, and a lot of those it's all in 90.1 and it's all in IECC. Beauty of it is they won't let you put anything less than what's required. So it's like I'm going to put in a 12 SEER. No, it says right there you got to have at least a 13 in this particular example. So guess what? You're going to put in 13 if you're going to pass or not. And then we're just verifying on the plans or the documentation we're getting from the designer that says, oh, is that really what you're putting in or not? And then we can use plants. So we've got different things that are using heating and cooling plants, which may or may not be happening. These are going to be fairly large facilities or campuses. You'll see that. Then we have the water heating or the service water heating piece. What are we doing? Is it storage? Is it instantaneous? Does it have a circ pump? Does it have heat trace? Does it serve a pool? Then it's going to ask for what the input rating is because, of course, it depends on the input rating. It depends on how efficient it needs to be. So we need to know how big is it? What's my turnaround there? If it has a circ pump, clearly we're going to have requirements then for circ pumps, recirc lines, insulation, controls. Yeah, we just can't have that pump running continuously. There's nobody in the building. Why are we making sure there's hot water to all the different faucets when nobody's there using it? Same thing. Fan systems, this again is just a place where the designer can start to load in different fan systems that he's got. These would be for very large systems where we start to regulate efficiency of the motors themselves. Then they kind of go in and just, put in what they are, if it's supply or return, and what it's doing. And then we put in the horsepower, and again, based on the volume and what it's doing, it already knows what the code says. So you're not going to be able to put in anything that's allowed. Then what we have here, and we'll get to this when we get to the online step, it'll be much more interesting. This is a place where you can, the designer can now go and actually go through this little checklist, okay? And so you see here we've got these different buttons for all the different places that we can do our checklist on. And the beauty of these checklists is that it gives us an indication of what's important, okay? You're going to have colored zones, and when we get to the application here, I'll show you what that is. What's the top 10? What if we don't do anything else, can we make certain that these things have been checked on the plans, that they're actually showing correctly on the plans, and that we're actually going out in the field and verifying it? So we don't have time to do, but can we take the time just to do the top 10, what I refer to as the top 10? And we'll show you what that looks like. But the designer has the option to go through here and actually put a little checkbox and say, yep, required, going to be met, and here's the reference. Here's the page where you can actually see it. That's where it's going to be. And so it helps not only our plans examiners like, oh, well, here it is, 8-47. Here it right is. And the guys in the field, and hopefully the guys in the field get the COMCheck checklist. They can use it for their inspection, too. And if they say, well, where's that on the plans? Well, it's right there. Wouldn't it be nice if all the designers did it? I'd probably find, 2 in 10 might do it. 9 times out of 10 is just blank. Then we start to actually get the report itself, and this is what we're used to seeing. Here, we're simply just verifying the information. You know, is it the right code cycle that we're on? Is it a right project? Is it a retail shop? Is it in Parker, Colorado? Is it new construction? Was it a remodel? Is it an alteration? Is it an addition that we're trying to do? It's got, you know, our glazing in here. The nice thing is that with the designer, if they can fill out where the construction site is, who the owner is, and who the contractor is, wouldn't it be nice? And this is where that tab is here. This is the additional efficiency, reduced interior lighting power. So requirements are implicitly enforced with the interior lighting allowance calculation, meaning that when that designer went in and did it, as long as the lighting piece, compliance piece says the same thing, then we're in good shape. Then we're in good shape. It should say the same thing. So that's just the upper part of the certificate. Again, here is the lighting, and notice it says the same thing. Okay, lighting powers, we're good. I'm just showing you the top half here. We'll get to the rest of it here when we do our example, which is at 9, which is good. Then we go to mechanical. Okay, so we see again, additional reduced lighting power. We're in good shape. Everything else is the same. So here we get to the piece where we get the whole thing. It happens to be this particular project actually chose enhanced interior lighting controls, and that's actually true. It happened to be a motel. Yeah, Steamboat Springs, so a little bit cooler there, climate zone 7. So here you can see that they actually they got slab on grade, and they just pretty much glommed everything together. And you can certainly do that. Not with that. This is another piece that we generally see. You'll notice this one passes. 0.0% better than code. So it just has to be as good as prescriptive. Doesn't have to be better. And that's what this one's saying. The other piece that we see here is what we see a lot. Notice what my Windows said. Product ID not available. Solar heat gain coefficient was a 0.22. My projection factor, they're saying, was a 0.29. So when they did their math, that's what they came up with. They got, what, just short of 9,800 square feet of window area. But look what they used for the U value, 0.29. If you see a 0.29, you automatically know it is wrong, incorrect. Why do I say that? Because that is what the glass is. If you see a 0.26 or a 0.29, you almost automatically know it's wrong. So this place, well, they were in trouble because they were passing by 0% and the windows aren't correct. Right? There's no way if a commercial window is coming in at a 0.29. That is one dynamite window. At a 0.29, that's dynamite. It's the glass. Okay? So this brings us to what we're looking for. So when I looked at this, I mean, I'm double checking my square footage areas, and I'm not talking about getting down, and especially when you got 38,000 square feet of exterior wall area. I'm looking to see if they missed a floor. You know, if it's a 5-story building and I only got 4 stories worth of exterior wall, what happened to the 5th floor? Whatever. Yeah? Because we could all do the same takeoff and end up with different numbers. So I don't lose any sleep over, you know, a few hundred feet here and there. I'm looking for the biggie. There'll be plenty of times where they've forgotten like entire walls or an entire floor. And same with the roofs, same with the windows, same with any of that. I'm not worried about a few square feet here and there. Here, we're just taking a look at maybe what they've done. Maybe they've got an insulation schedule, which is okay with me. I don't need to see it on the details. What I need to do is I need to see an installation schedule based on the wall type, okay? Because I don't know how many times these details, get pulled from one job to another, and it might be different than what the table says. And now I'm saying, dude, you can't say an R20 here and come over to my installation table and it says it's supposed to be an R11. I mean, whatever it happens to be. It needs to be consistent. And I just told you about square footage that I don't get big deals about. What I do get big deals about are the R values and the U values. Okay? So if they're saying it's an R10, I'm on slab on grade, which is what they're saying, I best be seeing a slab on grade that's an R10 and it comes to the top. I best be seeing an attic that's got an R38, and I best be seeing an exterior wall that's got R19 cavity and an R5 continuous. I best be seeing that on the plan. Because if I don't, it's wrong. Move on with life. Change it. Change the spec, change the detail, change the COMCheck. I don't care. You need to coordinate it. It needs to be coordinated. Otherwise, it won't work. So, back to windows. So this is what you're going to start to see. This happens to be Conair. Conair is a gigantic frame manufacturer. They make all kinds of frames. 9 times out of 10, this is what you'll see for plan review. So this happens to be their curtain wall system of this particular frame type. So this is probably about 40 or 50 pages long. It gives you gives you the engineering for it, gives you the sizes, gives you all the cuts and the details, wind loading charts and things of that nature is going to hold up. What it's going to have in there is the thermal performance piece. This is what you're going to see for plan review, and this works. I accept this for plan review. What we're looking at here is I'm going to blow up one of those bigger pieces here. No, they didn't. The thermal transmittance, so the U factor. And so what this U factor is relating to is what's my glass. So remember we said the glass in our particular case was a 0.29. Remember that? So it's right in between. So we're going to go over here and notice that it's going to be somewhere between a 0.38 and a 0.39. That's the overall U factor, and that's important, okay? Because it's a whole lot worse than a 0.29, is it not? Because that's what we're looking for, the overall assembly's U factor. Just remember when we were looking at the wall, we looked at all of the components in the wall, did we not? Yep, we did. Same thing with a window. It's the glass, it's a spacer, it's the frame. And the glass is great. There's no doubt about it. Glass is awesome. It's everything else that really makes it not good. Yeah, it's everything else. So unfortunately, I'm noticing that I don't have the certificate that you get on site. Sorry about that. What it's going to say right at the very top, it'll say right at the very top, NFRC certificate, and right below that, it'll say use for code compliance. You can't miss it. Okay? I apologize. If I got time at the end, I'll find it in the files and bring it up for everybody. Sorry about that. All right, so can a rest check and a COMCheck complete on the same building? Absolutely, positively. No problem whatsoever. Can be done. We'll do that. This one, I think, floor, yeah, this one didn't have a ceiling. This one didn't have a ceiling on it. And I thought this went through, yeah, this didn't have, no ceiling. This happened to be no ceiling, and you can see it shows 4% better than code. So you're wondering, how does that happen? How can you do that? How in the world does ResCheck allow you to do that? Well, the ResCheck has no clue, dude. All it knows, or the COMCheck, pardon me, it just knows what you put in. It's just software. It's just doing math, okay? So all it knows is to calculate what you put in there. You'll notice that, this one happened to be north, south, east, and west. This one happened to have 4 walls. But you'll notice on some of the others we looked at, it had 1 wall. Well, the software is not going to come up and say, well, you only got 1 wall. Doesn't most buildings have 4 walls? Oh, I don't know. Maybe it's only it's a triangle building. It's only got 3 walls. Yeah, it doesn't know. This is where the human factor comes in and says, hey, you know what? We got to have it. Here, wouldn't it be nice if they were to sign it and stamp it? Some require the engineers to stamp it. That's up to each jurisdiction. That's something that they can decide. So here's a res check. I just it's a 2-story, no floor. So it has no floor to it whatsoever. So what is it going to say? Well, it passes, but it had no clue that it had no floors. Well, it's because you didn't tell it to do it. So all it's doing is calculating what you input to the software. That's all it's doing. Okay? All right. Are we good? You like it? So let's do an example just for fun. Let's see if we can make this happen. So we are going to make an attempt. Well, let's do this first. We're seeing a really simple little drawing here. And I know you guys all have your calculators and your thinking caps on and you're ready to go. Yeah? Okay. So let's take a few, before we get into the software, let's just take a few numbers down here so that we can all agree to disagree or all agree on the numbers. Okay? So we've got a mixed-use shell building that's 50 by 250 feet. I got 10 foot of wall, 2B construction with a full 13 system in it. Well, I don't care that it's 2B and I don't care that it's got fire suppression in it. Doesn't matter to me. All I'm trying to do is figure out my thermal envelope. All right. So, and we're going to say, what do I have? I've got steel trusses with R30 continuous above deck. So if I took 50 times 250, I get 12,500. Does anybody disagree with that? Because I'm going to say I've got 12,000 square feet of R30 that's continuous above the roof. Yep. So far, so good. Okay. Not seeing any comments. Good. Let's see. We've got windows. So what do we got? We got 6 foot by 8 foot windows. Okay. So right. Yeah. 6 times 8. It better be 40. Let's see. Better be 48. Yep. Every time. And then how many windows do we got there? I'm going to say 1, 2, 3, 4, 5, 6, 7, 8. I'm going to say 8 windows. We're going to take that times 48. That's 384 square feet of window. Anybody disagree? Don't see anybody disagreeing. And we got a U value of a 0.38. And just for fun, we're going to say a solar heat gain coefficient. I don't know. Let's say, we'll call it the same thing, 0.38, just for fun. Doors, let's see, we got 3068 doors. And we'll call that 21 square foot a door, just for fun. And we got 1, 2, 3, 4, 5, 6. 21 times 6, 126. Are we good? And we're talking about a U, 0.38. Okay. Then we got walls. And it says it was metal stud at 16 inches on center. Oh, and it says it's got R15. So I got a 6-inch wall. So when I'm talking about metal studs, that's 6 inches, yes? Yeah. And I'm going to put in an R15 cavity insulation. Is everybody okay with that? I mean, am I good with R15 in a 6-inch cavity? I guess we are. My question would be is how are you putting, do we make a 6-inch insulation that's R15? I know of a 3.5-inch bat that is R15, and I don't know how to get a 3.5-inch bat on a 6-inch wall, at least not very well. Are they blowing it in? Maybe they're blowing in some stupid stuff. Maybe they're actually spraying foam and just getting to an R15. The point here is it's important not to know what it is, the R value, but what are they using, and is it going to work? That's where I would be at. Okay, let's see. So what do we have for gross square footage? Well, let's see. We got 250, 255, 1,500 linear feet. And since they're 10 feet tall, that makes it simple at 6,000 square feet. What else do we need on there? Any ideas? We'll move it along. Slab on grade, dude. It's gonna be slab on grade. Okay, slab on grade, and we're going to use what? 600 linear feet. It is the only one that we do not put for gross area. All right, so making an attempt to start COMCheck web. Didn't mean to do that, sorry. All right, so I'm going to go ahead and log in here. All right, so I don't know, we're just going to say new stuff. And since I've got it set up for 2018, Parker, Colorado, I'm going to leave it at new construction. What am I going to do for energy efficiency? I'm going to say reduce lighting. Okay, so I'm going to do, notice it tells me, you got to do something different. Let's do retail. And let's say I'm going to do reduce lighting power. Oh, got it. Building area. It's non-residential, and we're going to say it was 6,000 square feet. Yes. Yes. Yeah. That shouldn't be working like that. Fascinating. Notice I had to change it to building area method before I was allowed to do reduced lighting power for retail spaces. It's fascinating. So I'm going to pick office instead. I'm going to go back to interior. Yeah, fascinating. Where does it say that in the code? Somebody look that up for me while I'm playing with this. Look it up. I don't think there's anything in the office or anything like that. It says when I use reduced lighting, I have to use building area. Fascinating. Isn't that wonderful? Well, let's see if we can get away with it yeah, now I can do space by space. If I pick enhanced interior lighting controls, yeah, that just means more controls. Back to retail. Fascinating. So has anybody found that answer yet? I am.
I'm looking into it now, and I don't.
I don't think it exists.
It listed in the additional efficiency packages section. But,
right. Yeah. Well, no, I'm sorry, folks. You get to learn with me. How about that? Here's efficiency on state. So here, Oh, service water heating.
that's, yeah.
Dedicated, where am I? Oh, the digital control. Okay, reduce lighting power. Total connected lighting power, right? In accordance with, shall be 90%. Yeah, okay. So 40531, yeah, duh. It's the same thing. And you go back to this one. I'll try not to change screens too quickly. Then, right? Oh, got it. Oh my goodness sakes. All right. I did not realize that. You know how many times I've taught this? How many times I've done it? Okay, so it said method, light it in accordance with section C40532. Okay, C40532 is building area method. What actually it goes to both. It goes to the first table or the second table. I'm going to have to, that's another thing. The last time I did this, I found out a mistake too. Well, this is a mistake. It should not be doing that. They're really going to love me there at COMCheck on reduced lighting. I'll send them a note because that shouldn't work, and I'll have to check on the desktop and see if that if it's desktop too. Okay. All right. So back to this. So we got 15 minutes. I'll just breeze through this quickly. So what we're going to do here is we got enough information here on the project to work with. So now we're just putting in what we've got. So I'm going to add a roof, and I said it was metal. What did I say? No, it's insulation entire above the deck. Create roof, and create a building area type. And I thought we did. Retail, we did. I don't know what that's all about. All right. And we said it was a continuous R30. Hit save. It said create a building area type, and I did. And for some reason it says create a building area type. Look at that. So I put in a roof. Okay? And I hit the check compliance, and look, I passed. Isn't that great? Okay, let's put in an exterior wall. And I said it was steel framed at 16 inches on center. And I'm not caring about the orientation. And I said we had a total of, oh, I put the wrong area in. It's not, I put the wrong, it's 12,000 or 6,000 for the, see, so who's watching me here? Somebody watch me. We had a cavity of 15, and I did the roof wrong. Edit. Oh, I can change the square footage without doing that. Okay, so it's only 12,500. All right. Okay, so now we're dealing with the steel frame wall, and we're going to add windows real quick here, and we're going to say metal frame with a thermal break. These are all going to be fixed. We're going to do performance, and we're doing a 0.38, and we're going to do a 0.38, and we're going to say pending, and it's going to say I can't do it. This is another mistake that they haven't fixed and I told them about, because clearly in climate zone 5, the lowest U value or solar heat gain, based on if I put no projection factors, and it doesn't matter what direction, the lowest I would ever have is a 0.38. And it says it's got to be a 0.35 or it's 0.25, which is ridiculous. So I put in a 0.35, 25, just so I can create the window. And then I go back into the window. Let's go ahead and put the square footage in. And we had what for windows? 384. And now I'm going to go back and edit that. And I'm going to say it's not a 2.5, it's a 3.8. And I'm going to update and say, oh, okay, it's okay now. See what I mean? Isn't that nice to know how the software works? Yeah, not so much. Let's see, so we did that. We got roofs, we got walls. Yes?
Gil, is that issue only in the web version, or is that also in
I do not know that question. I don't think it is. I think when you use in the desktop version, that doesn't happen. I've only found that particular piece to happen here. I am going to have to check about this reduced lighting thing. Don't know that if it happens. I just discovered it in the web. I'm going to have to see if it happens on the desktop.
Okay.
The same thing with floors. So I'm about to add a floor, and it's going to be so there's this concrete floor over unconditioned space, okay? If you were to choose that, and there are plenty of concrete floors that are over unconditioned space, think of a parking garage that's not conditioned, and you got apartment units all above it, and then believe me, it's a concrete floor, okay? It will actually, software will actually allow the designer just to put in perimeter insulation, and it'll show pass. Okay? We as humans have to know that that's incorrect. I emailed them about it, and I said, oh, well, that's fine. But when I create the floor, why does it tell me that the warning comes up that it's got to be linear? They said, oh, that's a good point. So clearly they haven't fixed it yet. You know, because we got to be smart enough to do that. So we're gonna edit that. So we got to know that. Guess what? Right? It's slab on grade, unheated. That's what we've got. And we're going to say we've got 2 feet. We're actually doing vertical 2 feet. And we're going to update the floor. And we're going to say we had what? It was 600 feet. And we're going to say we got 0 because we're trying to trade it off. Check compliance. Oh, look at that. Fails horribly. Well, I can tell you why. We got near enough insulation. So we put an R5 on the outside. See if that helps. No, it really wants something here. So you can see we can start to manipulate it now, which is what the designers will do, just to start to see what it is we can do. Well, we're going to make it happen because it's essentially a prescriptive house or a prescriptive building. So I put in R10, perimeter, 15 cavity, So if we were looking at climate zone 5, especially in metal, it's always going to want cavity and continuous. Most buildings don't want to do that. I actually threw in R38 there. So for the interest of time, we're not going to do lighting. Until building categories. I still don't know what that's all about. Did I not do that? Oh, I guess I didn't. That's fine. We'll say it's sales area. And if we were doing a shell building, for instance, we wouldn't do any of the lighting. The only thing we do maybe is exterior lighting for that. We wouldn't do that, and we may not even do the mechanical on it at all. Okay. Let's just get to the report. Here's the requirements piece, the pieces I was telling you about, and the different places where they can do it. Because I didn't put any lighting and I didn't put any mechanical in, that won't show up. So I'm going to hit the PDF here. I'm going to show you what the white. No. Okay. Here, we're just seeing what I entered, but the piece I want to get to here is we didn't put any other stuff in. So here are the areas. And so you'll see that you've got 3 different tiers, Tier 1, Tier 2s, and Tier 3s. So everything in white, those are the biggies. Those are the ones I was saying, do the biggies, do the whites. So if we don't do anything else, let's make sure that we've got, does this comply, does it not? And these are the comments where the designer would have any comments, and the instructor or the inspector, rather, can say, did we see it, or could we not see it, or was it not applicable? Then we get to slab edge. Looks like it's a Tier 2 piece. And so we just go through, and the thermal envelope will have white, categories, zones 1, 2, and 3 to deal with that. But then if we had more mechanical lighting, it would go into controls. But this just happens to be the thermal envelope piece that goes to it. So you can see we've got all these 1, 2s, and 3s areas in it. So honestly, if all you want to do is the white, then concentrate on the white. There's nothing wrong with that. Again, we would see a lot more if I had done more in it. Let's change to a different project where I've got stuff.
If anyone has any questions at this point, feel free to unmute yourself or write in the chat, and we can go ahead and address them. Gil, how often does the desktop version get updated? Is it every code cycle?
Well,
I'm assuming there's multiple updates, but
yep.
how often?
Yeah. It seems like it's every few months that they'll come up with a new version. Right now, I can't get to my desktop to see it, but I'm not sure what the latest version of the desktop is. But every time, it seems like every time I get one, I'll update. It's free, so it's not tough to do. But they'll do find the bugs and do some updates. I don't know. It seems to be a few times a year that they do that. I was trying to see what.
Sounds like it's also important to go and check against the code if there's anything that looks a little fishy too. Pretty frequently, it sounds like there's. Would you say there's more issues on the COMCheck side than there is the ResCheck? I know we didn't run into as many of those issues.
No, it seems like the COMCheck is it's more complicated. You know, there's certainly more to it, right? Than the ResCheck itself. You know, last time I did this, it was the floors that I ran into, and I thought, now that's fascinating. You can pass putting in perimeter when clearly it should be having insulation throughout the floor because it's separating conditioned and unconditioned space. And the software just didn't recognize it. And that's when I said, you know, wouldn't it be nice if you took out the little warning that says, you know, by the way, right? It should be linear, not gross, when clearly it should be gross because it's, you know, separating the piece. All right, so I'm not. I just wanted to get a report that had more to it. That's all. Wow, I did the world's best job because we had just got like 0 questions, so I must have just tore it up.
Good
okay,
job.
Here's one. So let's load this real quick. We got a couple of minutes.
Yeah, Gil and I will stay on the line for a few more minutes. If anyone does have any questions or wants to open it up for discussion, feel free to unmute your line. But looks like we're at the end of the presentation here. So thank you to everyone for joining us today, and happy Friday. And thanks to Gil for a great presentation.
All right, sounds good. We'll hang.
We will hang.
So here I'm just showing what something that's got more of the comments on it. So we got mechanical rough in here, check boxes. So these are fairly generic pieces. So there might be a lot of these things that may not happen. That may not even occur in this building, and that's why it's nice when the designer comes in and actually hits a little checkbox and says, you know, not applicable. You can see that on the screen. You know, and then we can decide, yeah, is that true? Because, you know, if we don't have a kitchen exhaust system, why would we even have it, right? So it would be not applicable. So anyway, hopefully that was at least somewhat helpful to folks. Oh, yeah. Yes, I most certainly, Michael, I will most certainly have a wonderful weekend, yes.